Testing. Let's see if this is working. Oh yeah, here we go. All right, hey everybody. I'm doing something a little bit different from my kind of other content that I've done in the past. Going to be running through a very quick introduction to Zephyr. Some of the people that have reached out to me or customers, they're kind of like wondering what is Zephyr, and then kind of like what are the basic components of getting some type of example to run. So we're going to be going through that today. You get open the slides here. So let me jump into Zephyr. So Zephyr, and why should you care? So Zephyr allows you to build one uniform code base and utilize that code amongst different processors. So we're talking about developing embedded applications, and maybe you're sourcing at the beginning a certain part. Could be a Nordic part, could be whatever, Espressif, ESP32, so on and so forth, and you want to change that part. Now, normally in the past, that would have been a little bit more complicated, mostly because all of these guys have different IDEs and development platforms that you're going to be tied into, and there's not really any good way to translate between the two. So Zephyr crosses that gap, so you don't have to. You don't have to rewrite everything from scratch every time you want to change a processor. So this is really nice. So I'll be showing you some of the main utilities in Zephyr that you are going to become very familiar with by the end of the time when you're actually kind of developing your own code. This video is not going to be a giant overall. It's not going to be like a giant how-to from the beginning to the end. There's plenty of documentation on that, but if you are interested, please let me know. But for now, I'm just going to go through some of the most important the utilities used in Zephyr. So West is the utility for building and flashing. So we're talking about, this is the main one that you'll need to install before doing anything else. Of course, there are other dependencies like CMake and Ninja, so those things will have to be on your system as well before setting things up. And hopefully, fingers crossed, in the future, you won't have to set those things up yourself. And then, obviously, West itself is not like a standalone binary. It's actually built on Python, so it's essentially like installing a Python library. So pip install West, and that's how you get it. So you can see here on my little terminal window here, I just popped open West. You can see there's a bunch of options: init, update, list, manifest, diff, status. The ones that you are most likely going to be used a lot is the West build command, and maybe the West Flash, depending on what you're going to be doing. West Flash utilizes typically an external programmer that is hooked up to your board that you're working with, and it'll interface through that device. So say you want to program directly to the board, program a bootloader, or program a merged hex image, you can use West Flash, and it'll use whatever flashing infrastructure you want to use. There's different options for this, including, and typically it's when the board is set up. So if you're using an already existing board, most likely you are just going to be using whatever was provided. But for like Nordic boards, usually they have an OpenOCD configuration /PyOCD, and then they also have an NRF JProg configuration as well. So those are some of the options that get run when using West. Remember, West is basically just simplifying a lot of things that are happening on the background. It's kind of a wrapper for a lot of the underlying tools, like the NRF JProg, like CMake, like Ninja, things like that. CMake and Ninja help things build, and then NRF JProg for Nordic projects. That's how you get the code onto your devices. MCU Manager and New Manager. So for the NRF 9160 Feather, we're going to be using MC or Newt Manager. They're one and the same. They're literally, MCU Manager was renamed from Newt Manager, mostly because Newt Manager is kind of referring to Minute or Apache Minute, which is another RTOS, so we don't want to get confused there. The reason why it's called Newt Manager for those NRF9160 Feather users is because it was easier to make changes to that version of the code, mostly for speed improvements, because we are loading binary images via the onboard Flash interface, or the onboard UART interface, I should say. And this utility basically allows you to communicate with the onboard MCU bootloader. So you can talk back and forth, you can issue commands, you can reset, and you can program images as well. You can do updates. This not only works over serial, but it also works over USB. MCU Boot also has support, like if you have an update or update capabilities and your device has Bluetooth, you can update over Bluetooth. So very handy as well. Again, here's like the output of Newt Manager. Newt Manager typically, for at least for the NRF9160 folks, needs to be installed kind of manually on your machine. Of course, everything here is a Mac, but it's fairly similar. If you're on Windows, you'll just need to add it to your path so you can use it with command prompt or with PowerShell. So something to keep in mind. So I'll just run through and build a quick example. Not going to pull down a full repository because that would take a good amount of time, but just to show kind of what the flow of using both West and Newt Manager. So let me pop out here. Let me switch over to terminal here. So we're going to jump over to NFED, or NRF9160 Feather drivers and examples, and then we'll go to samples. NFED, and then samples, and then we'll go back one, and then go to let's do the AT client. I think that's a pretty standard one that a lot of folks start with. So here we are in the sample itself. So we're starting at NFED samples AT client. Now what typically we do in any type of, or what I recommend at least for any type of Zephyr install, is that you're going to be setting up a Python virtual environment for each project. This mostly keeps things containerized, or contained between your different projects. So say you have different versions of Zephyr on your machine, or different projects that use different versions of Python, it can get pretty dang hairy. So what I do is I just create a virtual environment, which I did earlier. It's in the a couple directories back in nbin, and then we just basically source this script and it'll set up the path for the environment, so we'll be able to access everything within that path. So what happens here now, I have a terminal. You can see I'm using fish, so it also shows you like, oh, I have a Python environment set up, version 3.9.7, and we should be able to access anything that's installed there. If you don't have West installed, this would be a good opportunity to install West if you're just setting it up for the first time. In this case, it's already set up, so I'm just going to do West build. So this will implement or start the build process, and then simply we need to select the board name for the board that we're going to be targeting for this sample. In this case, I'm just using the NRF9160 Feather. I am using NCS 1.7, which is the kind of latest version of NCS from Nordic. With that change, if many of you are users of the NRF9160 Feather, you'll notice that the board name has changed. The NS at the end of the board name now requires an underscore before it, just to be consistent with all the other non-secured board targets in Zephyr. Lastly, many of you are kind of used to like a make erase and then like a make build workflow. There's not really anything or like a clean, I should say. So like a make clean and then a build. The version of clean for West is -p. So the -p flag will basically delete your build folder and rebuild from the beginning every time. So good for starting at the beginning to get a good clean build, and then from there on out, you can get rid of the -p flag. If you ever do have weird issues with building, say you're kind of starting things up from scratch and like something's wrong, sometimes, and I've recommended this to people in the past, and I've also done this, is delete the build folder altogether. So if you look here, there is a build folder. That's where all the magic happens, and that's where it stays. So, and that's where you'll find your build artifacts when you are done building. So let's do a pristine build, and hopefully it'll work without breaking. oh yeah, so here's a good point, and this is great that this popped up. Whenever you're using Zephyr, is that you do need to set your toolchain variant and also your SDK install directory. This is different for different chips and different boards, so something to bear in mind. I'm going to be using an ARM toolchain, but like ESP32, they have a completely different toolchain that you're going to have to set yourself into these variables. Sometimes you can actually add that to the CMake file, and maybe that's something we can go into in a different show if you guys are interested. And please, if there's anything here that you're like, oh, I want to learn more about that, let me know in the comments, or send me a message, or send me an email, or send me smoke signals, whatever you want to do. So let's set those, and I have those in history here, so this should be pretty easy. So I'm setting the path to the toolchain, very important, and then basically the Zephyr toolchain variant is indicating that we're going to be using ARM, the ARM compiler, GCC ARM compiler. So we've set up the path, and we've set to say, hey, we're going to be using that particular path or that compiler. Now let's build. So I removed the pristine flag, if you notice here, because it's already deleted the build directory, so we don't have to do it again. And then it's just going to chunk along and eventually get there. But what it first needs to do, it needs to, for the NRF 160, there are actually 3 images that need to be built. You have the bootloader, you have the secure partition manager, and then also the application code. So all those guys have to be built, and then they get automatically merged together. So you simply, if you're programming from scratch with a programmer, you can load that hex file. It's called merge.hex, and it'll be inside that build folder. And I'll show you guys what that looks like in 1 second once it's done building. Almost there. Sweet. Last little chunk here. So I recommend, like, especially for folks who are just starting out with the NRF 9165, the AT client example is the perfect sample to like just talking to the device. You can get it to, as long as you have a SIM and an antenna hooked up, you can actually connect and just see that connection happen. For folks who actually are interested in controlling everything via the AT interface, this is also kind of a good introduction on what commands are necessary and things like that. So we have a merge.hex, and we're in business. So if you go to the build directory, and this will be the same on any platform. So if you're on Windows and you're building like this, it's going to be very, very similar. So we're in Zephyr. So there's a couple things that pop out. You can see Zephyr.hex, and that guy is an unmerged version of everything. And then you can see like MCU boot primary, and those are just a couple like app test, update, app signed, things like that. So these are all the intermediate files that good to know that they exist, but you don't necessarily need them. The one that's important for you is the app_update.bin. if you're loading anything through MCU Boot using Newt Manager or MCU Manager, this is the one that you'll be transferring over to the device when it's in bootloader mode. And then finally, back to the merged guy, as I mentioned before, this is the merged.hex file, and this is going to be the one that you're going to be using if you are using an external programmer. So I'm going to go back. Here we are. I'm going to jump out for a second and just show you I have an NRF9160 Feather plugged in, ready to go. It's also in bootloader mode already, so got the blue light here. So I'm going to jump back and program it with Newt Manager, and it should work. If I don't put my notebook on the keyboard. So let me get this guy. And I have all the details on like how to set up the nitty-gritty details for Newt Manager and things like that. It does require some setup instructions. It's all on docs.jaredwolf.com, and I'll show you that link in a little bit. Many of you are already familiar with it, but it's just a good starting point just to understand these tools. And hopefully, eventually, you won't have to use these command line tools as much. I'm really excited about kind of potential future innovations and things that make it easier for people to be programming in Zephyr. So, Newt Manager, you want to choose your interface. So I called mine serial. It's defining the baud rate and what the name of the serial interface is. So just important things there. It's at 1 meg baud, and the serial interface is the S. It should show up as slab underscore or something. Let's see. So yeah, I'm just using the tty.slab USB to UART. Then we're pointing to that app update.bin, and then at the end, what we're going to do is also run the Newt Manager -c serial reset command. So we're uploading an image, and we're also issuing a reset command, which should bring it out of the bootloader and into your application code. And again, this is all very similar for all the other platforms, Linux and Windows. Same idea here. Obviously, there's going to be differences between systems, but that's the general gist of things. So my board has jumped out. So now if I jump into serial interface here, and I give it a reboot, we got the AT host sample started. So boom, this was running a different firmware before, so I don't even know what was on it. And now we're running the AT host sample software, and you're connected, or I'm connected to the USB to UART interface for debugging and things like that. For folks who are new to this, who maybe are familiar with Arduino, some of the earlier Arduinos, you couldn't view the serial interface the same time that you were programming it. Same thing here. So you just want to make sure that if you do have this open, if you have your serial interface open at all anywhere, you want to make sure it's closed before you run Newt Manager, or else you just get timeouts and it'll just not work. Sometimes Newt Manager will kick the session off. So if I like open this guy, and then can I open? If I do like Newt Manager, I'm running a command here and another screen. Will it kick it off? If you're using a programming command like the image upload, it will actually sometimes cause the serial session to abort and quit. So something to keep in mind when you're playing around with uploading everything with Newt Manager. Jumping back. So you can get more at docs.jaredwolf.com, trying to improve it as much as possible for kind of the new folks or people who have just like never done this before. It's going to be a lot for you, and I'm trying to figure out what the best way is to kind of make it easy for folks moving forward. To be honest, Zephyr is not easy to set up, and there's a lot of gotchas, and it's most complicated on Windows. So Windows users, you're most affected here. hopefully, like I said, I have some ideas about it, and there are some rumblings and talks about improving the experience. And I know Nordic just came out with their own kind of SDK extension for VS Code, so that's something very handy that might be useful for you guys in the future. But keep an eye out. I'm hoping and staying positive about what's available out there. So thanks for watching. Hope you found this useful. If you did, please let me know, because then I can kind of plan some more content. I want to kind of post something quick every week, sometimes longer, sometimes shorter. It's really up to you guys. So do all the things, and I'll see you in the next one.